Okay, this is another try to understand what's going on with that machine. Because turret is not working, the driver is damaged. We switch it off. So there is no turret at all. So I can do a following test. I can turn on the machine and press APO. But what we did is we connected an oscilloscope directly to the 230 volts, 50 hertz connector of syntec computers. That what we see on the screen is just zoomed in a sine wave. Yeah, so that's the power delivered to syntec computer. What I did is this is a special way of connection, but let's turn on the machine. Okay, mostly nothing changes over it, and then we press APO. Okay, and now main spindle is powered right now. Machine is stopped, but please take a look there. Over the sign of the power, there is something coming from the main spindle. There is a noise, yeah, and little jumps between. But please take a look. The noise in the frequency is about 100 milliseconds. 100 microseconds. Sorry, 100 microseconds, because this is the distance in between. Okay, and let's make a test. Let's turn on A axis. Nothing happened. Turn reverse A axis, and turn on B axis and stop it. And right now I will turn on the spindle. Yeah, this is only 10% of power, and you can see a change of the frequency and the more noise of it. Of course, when spindle runs in the higher power, the peaks are higher, but the frequency is something like that. So let's change the direction of the spindle. Yeah, so just to be sure that this is the spindle, I switch it off. I mean power for the main spindle. Okay, so sine wave back is perfect. So I think this is the proof that the spindle sent some unwanted frequency directly to the syntec computer and another part of the machine. It generates too big noise. Yeah, this may be a reason of the machine damage, and we need a solution. Maybe the spindle is incorrect, maybe it needs some filtration. But from outside, there is nothing wrong going on to the machine. When we switch off the spindle, the sine wave is perfect.